In this video, I'm going to be explaining how I made a zeroing script for my CNC machine. Here is the machine zeroing itself. It moves from the home position and then it plunges downwards. Now there's a cable connected to the aluminium block in the bottom left-hand corner of the picture. And when the tool touches it, it completes a circuit telling it that it's reached the bottom and that's the zero position of the tool. That aluminium block set below the spoil board so that it's out of the way of the cutting head. And once it's moved back to a safe Z, the machine will return to home position. In Mach 3, we accessed the script by typing in M200, which was just typed there. And then you can see the machine starting to move into position. So it's moving over to the head, over to the block. Now this is the diagnostic panel in Mach 3, which shows all the coordinates and the status of all the inputs. So I've reached the block, and now we're starting to plunge down a Z. I've sped this part up just to make it a bit faster for you, but as we get down to nearly Z minus 20, or a bit over Z minus 20, you'll see that the digitize input is illuminated, and now the machine will set 0. There it was. It'll set Z as 0, and then it'll move back up above the spoil board. Here is the code in GitHub that I wrote to zero the tool. So here we have some variables to set the position where we want to touch the tool plate, and a few other variables that are going to be defined further down in the code. So the first one we've got up here is is zero plate touched, and it's a Boolean true false, and that'll be set to true once we've successfully touched the plate, and then we can say that the machine is zeroed. So we set that to false in the first instance. Z probe depth is set to -30, and that's how far from the current position the tool will plunge. If we were to go greater or indefinitely, if something went wrong, the tool would just keep traveling down and crash into the bed of the machine. So 30 millimeters is a sort of an acceptable number that I set. The Z safe position is plus 30 millimeters. So once we've zeroed the tool will move back to 30 millimeters above the spoil board. Now for the plunge rate, we've got 100 millimeters. So when we're zeroing, the tool will plunge at 100 millimeters per minute, and then once we've zeroed, it'll retract at 1,000. And feeding and moving into position over the zero plate will move at 2,000 millimeters per minute. So on my machine, I've set the touch plate to -3 millimeters, so that's hard coded into the script here. And that's variable, obviously. As we re-level the table, that'll need to be reduced as we cut the spoil board down and shave it down so that we can reuse the spoil board. Now, from absolute 0 machine coordinate, the zero plate is located at plus 45x and plus 95y. The next function is a dialog box that's shown to the user. So it's just prompting the user to make sure that the tool's in a safe position to start moving. And they select OK. It'll run to the next step. Otherwise, it'll trigger an abort, which is this line here, and that'll run the e-stop. So in this line of code, we're moving over the touch plate. So we're moving to that X and Y coordinate defined above.
and the feed rate of 2000 millimeters per second, messaging the user to tell them that we're zeroing, and then we're doing a check on the configuration. So need to make sure that the machine, Mach 3 has been configured for auto tool zeroing, so that's defined by this signal 22. Then we're getting the current machine position. So whatever the current Z is set to, we get that position. So we're looking at get absolute position in the second index. So X is 0, Y is 1, and Z is 2. So we're just getting that position, loading it into there, and then the probe coordinate that we're going to is the current position minus that 30 mil probe depth that I mentioned before. The next line is a G-code command, so we're calling G31, which is a probe, and we're going at Z. We're going to Z, the probe coordinate that we've just defined, and at the plunge feed rate of 100 millimeters per minute. Now this is a while loop running. So while the machine is moving, we're checking this OEM LED 825. Now that's defined for the circuit, so earth to the spindle. So when the spindle touches earth, that'll equal -1, and then it'll set that boolean, the is zero plate touch, to true, and that'll tell us that the machine was successfully zeroed. If not, it'll be set to false, and at the end of the program, it'll tell the user that the zeroing was unsuccessful. After we've done that, we call set Mach02, so that's setting the Z-axis to 0, and then we're moving to the safe Z with the code 4053 G-code call. And then at the end of the code, at this block of code, we're just checking, was a zero plate touched or not? If it was, we're reporting that out, reading that out to the user, and then moving back to the home position. If it wasn't, we're telling the user that the zeroing failed and what to do about it, and also triggering an e-stop so that any following code won't run.